A lot of data analytics questions can be answered with simple descriptive statistics, correlations, and t-tests. There are some data analytics questions that need more advanced statistical approaches. Okay, and you've already had if you haven't had statistics or advanced statistics, this course is not designed to teach you advanced statistics. But rather help you understand how to apply an advanced statistical method in Python. Right? So what we're going to try to do here is not help you give you the answer, but help you understand the process to figure out how to take a method that you learned in your statistics course and find the code the process to do this it's irrespective. The process is the same. So the process to figure out how to take the method and find the code is the same irrespective of the method that you are trying to find. So what we're going to do is we're going to do an advanced, not really advanced, but a simple, a little bit more advanced than what we've been doing. And try this on. So for our Python search for advanced methods, let's identify a method that you have likely seen in a number of your previous courses. Regression. All right, it's an advanced statistical model. It's not crazy advanced, but it's still a model above and beyond descriptive statistics, correlations, and simple t-tests. All right, so what the regression model attempt to identify, they attempt to identify the association of a dependent variable or a response variable with other independent variables or predictor variables. In our correlation example that we used before, we could make the argument that sales volume, or dollars, is the independent variable. Or the predictor variable. As that changes, other variables, such as freight expense, change. Right? So logically, it is not likely that sales would depend on the changes in freight expense. All right? So again, we're just trying to come up with what we think this logical model is going to look like. So when we think about the many aspects of business, sales volume is a critical independent variable. That may predict other variables. Now, sales volume can also be predicted by other things. So sales volume might be predicted by population demographics, marketing, advertising, right? So in that particular case, sales volume may be related to advertising expense versus advertising expense related to sales volume. So we could again, you just have to use your business mind in articulating what your problem is. So let's take our two variables from the correlation exercise. So we're trying to build on this correlation exercise we did and form a model. All right? So we believe that sales volume should influence freight expense. We know this, or we believe this, because freight expenses are a function of how much we need to purchase to satisfy customer needs. Right? So the customer needs increase. Sales. Freight should also increase. Right? You're trying to come up with kind of the logical argument here. And we saw a positive relationship between sales dollars and freight expense, right? That positive 0.39 that we had showed us that we have a positive relationship between sales and freight. All right, so I went through, did a little bit of research, and came up with this package called StatsModel. So we are going to use stats models as our package. there are other modules, other packages that will do the exact same thing. scikit-learn.org is another source of advanced models. All right, so if you're looking to find an advanced model and you're looking for what the Python code is for it, you can go to scikit-learn.org. All right, okay. So we kind of set it up, and we think we know where we want to go, and that's reading in some data, and then starting to set up this particular regression model, and we'll cover that in our next videos. But we just want to at least kind of set up the problem in this video.